Morning, everyone. So today I would like to present my final review of my project. Myself, Asia, and my topic is a novel multimodal speech emotion recognition system created by Kiran BK, Assistant Professor, CSCD, LSS College of Engineering, Palakkad. This is the outline of my presentation: introduction, objective, literature survey, flow diagram, modules, paper publishing details, conclusion, and references. Correctly perceiving other people's emotion is one of the key components of good interpersonal communication. Emotions make conversation more natural. They can add or remove ambiguity, and they can change the meaning of what is being communicated altogether. Due to the importance of emotions in human-to-human conversation, automatic emotion recognition has been one of the main concerns of the human-computer interaction field for decades. The main objective of my project is to investigate the difference between self-trained and pre-trained models in order to determine the best model for multimodal emotion recognition, and to build a model which is used to recognize emotion based on variable length audio inputs and text. Literature survey, paper 1, a multimodal hierarchical approach to speech emotion recognition from audio and text. Methods used: hierarchical multimodal. Advantages: feasibility of leveraging contextualized word embeddings to improve the performance of emotion recognition systems. Disadvantages: not mentioned feature reduction techniques which can reduce training time. Paper 2, multimodal speech emotion recognition using audio and text. Methods used are deep dual recurrent encoder model. Advantages: multimodal, and disadvantages: vanishing gradient problem. Paper 3, ImageNet classification with deep convolutional neural networks. Here the method used is CNN model, and advantages are to reduce overfitting by adding dropout layer and data augmentation. Disadvantages are need GPU. Paper 4, emotion detection from text. Methods used are emotion detector algorithm. Advantages: hybrid methods. Disadvantages: incapability of recognizing sentences without keywords. Fifth paper is attention is all you need. Methods used here is transformer model. Advantages are attention mechanism. Disadvantages: high computational cost. Sixth paper, BERT, retraining of deep bidirectional transformers for language understanding. Methods used: BERT model. Advantages: ability to process large amounts of text and language. Disadvantages: high computational cost. Seventh paper, fusion approaches for emotion recognition from speech using acoustic and text-based features. Methods used: BERT and OpenSmile on MSP podcast and IMOCAP dataset. Advantages: multimodal. Disadvantages: several fusion strategies were tested and the results were not significantly different for the different methods. Eighth paper is multimodal emotion recognition using transfer learning from speaker recognition and BERT-based models. Methods used are BERT, ALEXNET on IMOCAP dataset. Advantages are the speaker recognition and spectrogram augmentation technique is used. Disadvantages: multimodal datasets are limited, so study done only on IMOCAP dataset. Ninth paper, multimodal emotion recognition with high-level speech and text features. Here the methods used are Verb2Vec 2.0 feature extraction and extract speaker identity features with resemblizer. The transformer-based models are used for text emotion recognition. Advantages: disentanglement representation learning. Disadvantages: multimodal datasets are limited. And this project is based on 3 systems, which are audio-only system, text-only system, and multimodal system. And the methodology used here is audio emotion recognition. Audio files are fed to the audio to spectrogram function, and the output of function is a 3D spectrogram. It will be then fed to the modified ALEXNET model, and the output will be a 256-dimensional vector. And the signaling SciPy library is used to extract the spectrogram of the speech signal. And the text emotion recognition, here the text data is fed to the BERT, and the BERT will generate 768-dimension vector. And multimodal emotion recognition, here concatenating the audio and text embeddings to generate a combined embedding and fed to the classifier for emotion recognition. The model used ALEXNET and BERT. So this is the flow diagram, how the project works. First, you can see the audio files is fed to audio to spectrogram function, and here the 3D spectrogram was the output, and they are fed to modified ALEXNET model, and we will get a 256-dimension vector. And here the text data is passed to the BERT embedding, and we will get 768-dimension vector. Both these vectors are concatenating here, that is concatenate these embeddings to and fed to the classifier, and the classifier will find which emotion: angry, happy, sad, and neutral. So this is the BERT architecture. Here you can see an input embedding, inputs, positional encoder, multi-head attention, add and knob, feed-forward network, add-on knob, and here you can see 12 encoders. Here the base BERT is using base 12 model, and this is the architecture of ALEXNET. Here you can see various layers. And the modules here, the main modules in this project is data collection, data pre-processing, and classification. Data collection, the IMOCAP dataset 22.5 GB is collected from SAIL Lab at USC. IMOCAP is a licensed dataset. And the multimodal dataset interactive emotional didactic motion capture IMOCAP was collected at USAID's SAIL Lab, and it is active dataset. There are 5 sessions in the IMOCAP dataset. Each session has multiple manifestations of each emotion, such as audio, text, and so on. The dataset contains diverse emotions such as neutral, frustrated, angry, sad, happy, excited, disgusted, surprised, and frightened. Only 5 emotions were chosen to make an Excel file: angry, happy, sad, neutral, and excited. So this is the data pre-processing stage. Here you can see a pre-processed IMOCAP dataset, which is having 4 attributes: session ID, text, label, and process ID. In data pre-processing step, an Excel file was created for the purpose of text emotion recognition. It includes 4 fields, which are section ID, text, label, and process ID. The session ID denotes the ID number of the speech signal. The text denotes the text transcript of the speech signal, and the process ID denotes the corresponding process session ID of the selected text, and non-selected text transcripts are labeled as non-selected. Labels are numbered from 0 to 4, corresponding to angry, happy, sad, neutral, and excited. And the text labels that are not selected are marked with -1. The Excel files consist of 10,040 entries. Classification. The sequential model is used, and a dropout layer with 0.5 as its value, and 256 in features from audio model and 768 in features from text model are concatenated and fed to the classifier, which produce 4 out features. A softmax layer is also used. Steps involved in audio model. Read the all files in a list at sentence level. Second, read this process transcription file to collect the labels. Next, test the ALEXNET input. Next, modify the ALEXNET input. Input code to ALEXNET with audio files. Input data shuffling and dividing the data. Finding the model parameters. Optimizing using Adam Optimizer. Training loop. Save and load the model. Testing loop. Printing, confusion matrix, and classification report. Steps involving text model. Load the doc files. Collect the text and label as list of dict. And create the training and test set. BERT model for classification. Using BERT sequence classification, training the model, testing the model, printing confusion matrix and classification report. And steps involved in multimodal. Read all the files in a list at sentence level. Read the process transcription file to collect the labels. Define who to extract the intermediate output. Create the new model. Create the modified model instance and initialize with the pre-trained model. Check trainable model parameter. Input data shuffling and dividing the data. Test the model. Optimizing training loop. Printing confusion matrix and classification report. So this is the results and discussion. This is the confusion matrix of audio model with 4 emotions. So this is the result. This is the classification report of audio models with 4 emotions. We get 54% accuracy. And this is the classification report of text model with 4 emotions. 71% accuracy. This is the confusion matrix of multi-model with 4 emotions. And this is the classification report of multi-model with 4 emotions. More emotions were included for emotion identification. The study began by identifying 4 emotions. The investigation eventually came to 5 emotions that could be recognized. Additionally, more emotions were tested in the study, but when tried with 8 emotions, the system complexity increased. So here, classification report of multimodal with 4 emotions, we got 94% accuracy. This is the confusion matrix of multimodal with 4 emotions. This is the classification report of text model with 4 emotions. Confusion matrix of text model with 4 emotions. Classification report of audio model with 4 emotions. Confusion matrix of audio model with 4 emotions. So this is the result and discussion. Model used is here is for emotions. Accuracy. Audio model ALEXNET 54%, text model BERT 71%, multimodal 94%. And when 5 emotions additional adding the excited emotion or audio model got 43% accuracy, text model got 64% accuracy, and multimodal got 91% accuracy. This is the first paper published myself and my guide Kiran sir. Speech emotion recognition deep learning approach in 2021 5th International Conference on IceMap. The second paper, myself and sir, a novel multimodal speech emotion recognition system accepted in ICICIT 2022 conference, and the conference date was on August 11 and 12. Conclusion: audio model, text model, and multimodal using PyTorch implemented successfully to recognize 4 emotions: angry, happy, sad, and neutral. The implemented audio model, text model, and multimodal got an accuracy of 54%, 71%, and 94% respectively. The audio model, text model, and multimodal using PyTorch implemented successfully to recognize 5 emotions: angry, happy, sad, neutral, and excited. The implemented audio model, text model, and multimodal got an accuracy of 43%, 64%, and 91% respectively. So these are various references. And a special thanks to the GitHub. The URL is given here. Audio and text-based emotion recognition. This was the base for my project, and I have modified those code from this URL. Thank you.